So in today's lesson, we're just going to continue our discussion from yesterday. On the MDI, they've given you an x that you need to find and a y that you need to find. So if we look at x, x is a central angle because its vertex is at the center of the circle. So we know that a central angle is equal to its intercepted arc. So if we follow this side out here and this side out here, we can see that the intercepted arc is this piece right here. So x is also going to be equal to 138 degrees. Same thing for y. If we look at where y is an intercepted arc, and its angle that it's associated with is this 27 degrees down here, which is a central angle. So if the central angle is 27 degrees, then the intercepted arc is also going to be 27 degrees. On the other one, you might have to think a little bit harder. This includes some inscribed angles and some central angles. So if we start with x, we can see that the vertex is here. In order to find an angle, you have to have an arc, and in order to find an arc, you have to have an angle. The two are related, and you can't find one without the other. So in order to find this angle, we need to find the arc that goes along with it. So if we think about extending the sides of this angle out, and if it helps you to make them go out past so you can see that it's actually intercepting this arc, that's fine too. The intercepted arc for x is going to be this arc that's all the way from B to this letter over here, which we'll call that D. All right. So if we look at this, we have this diameter here, which makes this half of a circle. So this arc is 180 degrees. So in order to find x, we know that its intercepted arc is 180 degrees. So if we take 180 and divide by 2, we know that x is equal to 90 degrees. Y is an arc, so it goes from B to A. Now the angle that intercepts that arc is this angle down here. So we can see that it is an inscribed angle, and it's 59 degrees. So remember, the intercepted arc of an inscribed angle is bigger than the inscribed angle. So if we know that the degree for the angle is 59, all we have to do, sorry, not squared, is multiply by 2, and we get 118 degrees for this arc out here. Then the last thing that we need to do is we need to find out this arc from A all the way around to C. So if we look here, we know that this arc from A to B is 118 degrees. We need to figure out this arc from B to C to find out what ABC is. We can see that there's a central angle right here, and we know that the intercepted arc and the central angle have the same number of degrees. So we know that this arc is 40. So to go from here to here, all we have to do is do 40 plus 118 is equal to 158 degrees. Same success criteria as yesterday. We still want to be able to find the measure of an intercepted arc or an inscribed angle. All right, so the next example that we're going to look at is we're going to find the measure of angle 2. So angle 2 is this angle right here, which is an inscribed angle because its vertex is on the circle. So in order to find that angle, we have to know what its intercepted arc is. So if we follow these sides out to where they hit the circle, we can see that this is the intercepted arc. This intercepted arc is also associated with another angle. So we can see that if we take the ends of that and follow it back, we can see that this arc is also with this angle here. So if this angle is 38 degrees, then to find this arc out here, we would just need to take 38 times 2, which is 76 degrees. Well, if we know that this arc is 76 degrees, then to find this angle, we just have to divide by 2. So 76 divided by 2 is equal to 38 degrees. So you should notice that these two angles have the same measure. And this is one of the things that we want to talk about. If we have inscribed angles, inscribed angles are congruent if and only if they intercept the same arc or congruent arcs. So if you look at this first picture down here, you can see that angle A, which is the red angle right here, intercepts arc DC. You can also see that the arc B, which is the arc outline or the angle outlined in green, also intercepts arc DC. Since they intercept the same arc, then that means that these two angles are congruent. Now these two angles don't intercept the same arc, but the arcs that they do intercept are congruent, which means that the angles themselves have to be congruent as well. Okay, let's look at the next example. What is the measure of arc EH? So first thing we need to do is we need to figure out where is this arc. So because there are two letters here, we know that this is a minor arc. So instead of going around the circle towards G, we're going to start at E and we're going to go around the circle through F and towards H, and we're going to stop when we hit H. Now in order to find this arc, we have to figure out what angle this is associated with. Some cases you might have one angle, some cases there might be more. If we look at this arc, we can see that there are two angles that are associated with this arc. So one angle is this angle right here, and the other angle is this angle right here. All right, now if we look at these, the two kinds of angles have their vertices in different places. This angle right here that's outlined in blue, angle EOF, has its vertex at the center of the circle, which makes this a central angle. Now we've learned before that the relationship between a central angle and its intercepted arc is that those two are equal. So if this central angle is 30 degrees, then that means that its intercepted arc, EF, is also 30 degrees. We can see that this angle is an inscribed angle because its vertex is on the outside of the circle. And we also learned that the relationship between an inscribed angle and its intercepted arc is that the angle is half of the arc. The other way that we can say that is that the arc is twice the size of the angle. So if we know that the angle is 40 degrees, then that means that the arc is twice that length, which would be 80 degrees. So to find the whole distance, the whole length of EH, or the whole measure of EH, we would take 30 plus 80 to get 110 degrees. In this next example, we're going to find the measure of each angle. So you can see that we have 4. 1, 2, 3, 4. And what I'm going to do is I'm going to label each of these vertices. So I'm going to call this A, B, C, and D. And that might help us a little bit when we're talking about arcs. So we have 4 different angles that we're going to try and find. We don't necessarily need to find them in order. And in fact, when I look at this picture, it seems to me that angle 4 would probably be the easiest one to start with. And the reason for that is because I know that this is the angle right here, and if I follow it out, I'm already given the measure of that intercepted arc. So its intercepted arc is going to be this one that goes from C to A. So remember, in order to find the measure of an angle, you have to find the intercepted arc. So we know that the intercepted arc for this one is 60 plus 80, which is 140. But that's just the arc. So in order to find the angle, we have to take that and we have to divide it by 2 because the inscribed angle is half of the intercepted arc. So it is 70 degrees. I'm going to take this out and I'm going to put a 70 here in its place, and that's going to help us a little bit later on. The next one that I would probably look at would be angle 1 or angle 3. So if I look at angle 1, here's the vertex of angle 1, and again, if I follow these sides out to where they touch the circle, here's my intercepted arc, this one that's outlined in blue. Now if I look, here's this diameter that goes through here. So what that tells me is that this blue arc is a semicircle, which means that it is 180 degrees. So in order to find the measure of angle 1, I just have to take 180 divided by 2. So the measure of angle 1 is 90 degrees. In the same way, I can find the measure of angle 3. So again, if I follow these sides out to where they touch the circle, that's a bad color choice, we can see that it's this one that I'm kind of outlining in the same color as the circle. So again, we have this diameter that's going across here, which means that this is a semicircle, and that means that there are 180 degrees here. So in order to find the measure of angle 3, we take 180 degrees, divide that by 2, and so the measure of angle 3 is 90 degrees. So I know that this is 90 degrees, and I know that this is 90 degrees. So the only one that I have left to find is angle 2. Probably the easiest way to do that, if you remember, we have a quadrilateral, that's a four-sided figure. Any quadrilateral has to add up to 180 degrees. So if we take all three of these and add them together, so 90 plus 90 plus 70, that gives us 250. 90 plus 90 plus 70, that's equal to 250 degrees. And then subtract that from 360. So 360 minus 250 is equal to 110 degrees. So that means that angle 2 is equal to 110 degrees. The next example, oh, I think I skipped one. Oh. All right. Last one. Okay. The last one that we're going to look at is this one. And I'm going to have to go quick through this. So you'll have to rewind or pause if you need to. We know that arc ABC is altogether 46 degrees. And we know that AB is 23 degrees because these are congruent. And we also know that BC is 23 degrees. So in order to find out, notice these are all angles that you're looking for. So in order to find each one of these angles, what you have to do is find its intercepted arc. And once you find the measure of its intercepted arc, you should be able to figure out what the measure of that angle is. So if we look at CFB, I'm going to outline that in yellow. CFB is this angle right here. So the intercepted arc is this pink one that's 23 degrees. So to find out CFB, this is an inscribed angle, so we're going to take 23 divided by 2, which is 11.5 degrees. CFA starts at C, goes to F, and then back up to A. So it's this whole angle right here. So it's this arc that goes from A to C. Well, we know that the arc from A to C is 46 degrees. So all we have to do is divide that by 2, and that's going to tell us what the measure of angle CFA is. So CFA is 23 degrees. All right, I'm going to erase some of these lines so that we don't get so perplexed by the next one, because this one is a tricky one. Okay, so we have CEA. Sorry, not this next one, the one after that. CEA also intercepts the same arc that CFA intercepted. So remember, when you have two angles that intercept the same arc, those two angles are congruent. So we know that CEA is also going to be 23 degrees. All right, then the last one that we're going to look at is angle CFAC, which starts at F, goes to A, and ends at C. So this is our angle right here. So in order to figure out that, we need to know what the intercepted arc is, which is this arc right here. All right, now, if we look at this, we can see that this part right here is a semicircle. But we don't want the whole semicircle, we only want from C to here. So we can take 180 minus 23, which is 157. So that gives us this arc down here. And then to find out what the angle is, we're just going to take 157 divided by 2 to get 78.5 degrees. All right, the last one is very similar. So if we look, we're looking for FCA. Well, FCA starts at F, goes over to C. Don't like that color. Let's do green. Starts at F, goes over to C, and then back up to A. So we're looking at this angle that's outlined in green here, this angle right here. So in order to find the angle, we have to know what the intercepted arc is. So again, you go from the side to the side of the angle. You don't go from the vertex to the side, you go from the side to the side to find your intercepted arc. So here's your intercepted arc. Now again, this yellow line right here through the middle, that shows that this is a diameter. But we don't want the whole 180 degrees, we only want from A to F. So we need to take 180 minus 23 degrees, and that's going to give us 157 degrees for this intercepted arc. This is an inscribed angle, so remember, in order to find the inscribed angle from its intercepted arc, you just have to take 157, again, divided by 2, which is going to be 78.5 degrees.